Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. In last class I have discussed chemical properties of aldehyde and ketone. Under that I have discussed acidity of alpha hydrogen of aldehyde and ketones. And also under that I have discussed aldol condensation and cross aldol condensation. Now I will continue. Today I am going to discuss now Cannizzaro reaction. Cannizzaro reaction. This is very important reaction. It is asked in all examination. IIT, medical, even in general examination also this question is asked. What is Cannizzaro reaction? I am telling you now. Cannizzaro reaction, just you can understand, aldehyde which do not have an alpha hydrogen atom undergo self-oxidation and reduction. Aldehydes which do not have an alpha hydrogen atom undergo self-oxidation and reduction reaction on treatment with concentrated alkali. In this reaction, one molecule of the aldehyde is reduced to alcohol while another is oxidized to carboxylic acid salt. Again I am telling you, aldehydes which do not have an alpha hydrogen atom. What is the alpha hydrogen atom? Means aldehyde with aldehyde group. If any carbon is attached and has hydrogen atom, at least one hydrogen atom, then that hydrogen atom is called alpha hydrogen. Correct? Means next to aldehyde group, carbon containing hydrogen, that hydrogen is called alpha hydrogen. Maybe one, maybe two also. Okay, but if hydrogen is there, that is called alpha hydrogen. But in this case, no alpha hydrogen is required. Okay, and this reaction is also called disproportionation reaction. Disproportionation reaction. Again I am telling you, aldehyde which do not have an alpha hydrogen atom undergo self-oxidation and reduction reaction on treatment with concentrated alkali. In this reaction, one molecule of the aldehyde is reduced to alcohol while another is oxidized to carboxylic acid salt. Means in reaction wise you can understand that there here two aldehyde or two ketone is used. Then now just you understand two aldehyde is reacting, two molecules of aldehyde. Then aldehyde means CHO group. Then formaldehyde you take as example. Then one H is attached, HCHO. Means here with carbon now this two hydrogen is attached and one oxygen is attached. Carbon oxygen is double bond and two hydrogen is there. One hydrogen of CHO has one hydrogen and other extra hydrogen is attached, formaldehyde, that H. Then 2H is attached with the carbon and that carbon is attached with oxygen with double bond. Now another molecule also you consider. Then you write in such a way that both hydrogen of the second formaldehyde should come near the oxygen of first formaldehyde. You consider like that for understanding purpose. Means 2 hydrogen of second formaldehyde is near the oxygen of first formaldehyde. Then in the presence of concentrated KOH or NOH anywhere, it will give you two product, methanol plus potassium formate. If KOH is there, then it will give methanol plus potassium formate, means CH3OH plus HCOOK. HCOOK. COO, that is the formate. A K is attached there, that is called potassium formate. Then now for a mechanism purpose, how it is forming, that I am telling you. Then easily you can understand the reaction. This is the overall reaction I told you, that 2 formaldehyde, 2 molecules of formaldehyde plus KOH, means concentrated KOH, it will give methanol plus potassium formate. This is the reaction, simple reaction I told you. But how we will get methanol, how we will get potassium formate? For that you have to understand the mechanism. For that purpose you consider that 1 formaldehyde, 2 formaldehyde is close to each other, and that 2H of second formaldehyde is close to the oxygen of first formaldehyde. Then now what will happen, that C and O, first formaldehyde, C and O double bond is there. Then that double bond will break in presence of OH ion. KOH is there, then it will give K plus OH minus. We remember. Then in presence of OH ion, that double bond, C and O double bond will break. Why will it break? Because that OH is negatively charged, correct? And K plus is also there, KOH. K plus OH minus is there. Then in presence of this, that C double bond O will break. Oxygen will take negative charge, carbon will be positive, means carbocation is created. Carbon is positive, oxygen is negative, correct? Then now what will happen, that this with positive carbon, OH will attach, OH minus, which got from the KOH, OH minus, that will join with carbocation, C plus, it will join. Then now 2 hydrogen is already there, third is OH, and fourth one is C and O. O is a negative charge. Then now this O has to go, and in its place H should come. Only then you can say methyl alcohol will form. But here CH2, OH is there, and 1 oxygen is attached, O minus. Then here actually what will happen, that now this oxygen is O negative. This happened with 1 formaldehyde. Okay, 1 formaldehyde now created on oxygen 1 negative and OH introduced. Then now come to the second formaldehyde. What will happen there? There actually this second molecule of formaldehyde, there that this here again we understand, because OH is present there. This reaction, what I am telling you, is a reversible reaction. Then this OH, what will happen, that because OH ion is there, then in presence of that OH ion, second molecule of formaldehyde, that hydrogen will, I can say, break. That hydrogen carbon bond will break. Correct? And after that, what will happen? This will create actually CO bond will not disturb. Only actually CO bond will also disturb for second molecule for short period. Okay. Here also what will happen in the presence of OH ion, second molecule formaldehyde, that double bond will also break for short time. And what will happen, that here also oxygen will be negative charge and carbon will be positive charge. Correct? Carbon will be positive, oxygen will be negative. Now just come to the first formaldehyde. There two hydrogen was there, CHH and OH, and carbon oxygen bond was there, single bond. Oxygen was having one negative. Then here that OH is there, with OH is there, that H will come out. That H will come out as this thing, H plus, as H plus. Correct? Then that will be also, it will be negative. It will be negative. Then 2 oxygen is negative there. And 2 hydrogen is already there with carbon. And 1 H came as a H plus. Now actually that this things only one H plus came. Now second H will also come out. 1 H came from the OH, from the first formaldehyde group molecule. Then now 2 oxygen is developed with having 2 negative charge. And 1 H will also come out from first formaldehyde only. Correct? Then 2 here, that H will come as H minus. That will come as H minus. Correct? Then now you can see 2 hydrogen is coming. 1 is coming as a H plus and 1 is coming as H minus. H minus. And that carbon now has 2 oxygen, both are single bond and having one electron. One electron. Then now here what will happen, because now H gone as H minus, then that carbon will have positive charge. That carbon will have positive charge. Then now 1 oxygen which is negatively charged with electron, because when bond broken, oxygen is electronegative. It has taken the electron. Then that bond will make a double bond. Means now 1 oxygen which was single bond, now it became double bond. And from there H minus gone. Then now 2 hydrogen. Now you can see 2 hydrogen is coming with second formaldehyde, with near the second formaldehyde molecule. First we came, now 1 H is there, C double bond O, and again 1 O minus. That is the formate. That is called formate. Because only 1 H is there and C double O and O is there. Then that is the formate. Formate ion. H O, 1 oxygen is a one negative charge and 1 became double bond. Then HC double O and other is oxygen having single bond, having 1 electron. Then here this actually oxygen has a negative charge, only single bond. Then from KOH, that K plus, that will attach here and it will form potassium formate. Potassium formate. Correct? Understood very clearly that from the first molecule, when H gone as a H minus, then that carbon become positive, and oxygen which broken as a double bond became single bond. That time oxygen was having 2 electron and 1 negative charge. Now it has again become double bond. Correct? Then other already OH, that H bond came out as H plus. Then 1 H minus and 1 H plus. Means 1 hydride ion and 1 proton H plus. That is coming to the second formaldehyde molecule. Okay. Then here what it will happen, that now that this second molecule also, it will double bond of C double bond O, that will break, then O will be negative and carbon will be positive. Then now positive hydrogen will join to the negative oxygen. Negative oxygen H plus will go to the O minus. It will form OH. And now oxygen became, this carbon was positive. When double bond broken, then O was having negative, carbon was having positive. Then with this oxygen, H plus joined. 2 H came, then one was having H positive, that joined with oxygen. Now it became OH. O became OH, and carbon which was positive, but this positive carbon H negative joined. Then now already 2 hydrogen was there, now it became third hydrogen, means 3 CH bond. Correct? 3 CH bond and O became OH. Then you got methyl alcohol. This is the mechanism. Means for one time carbocation will form with in one formaldehyde, one molecule of formaldehyde, carbocation will be formed, and second also carbocation is forming, but on oxygen negative charge will be also there. Correct? Then that H plus and H minus will reach to the second, then plus will go to the minus, and minus H minus will come to the plus carbon. Means O minus, near O minus, H plus will come, it will form OH, and H minus will join to the C plus of second molecule of formaldehyde. This is the mechanism. Now second reaction also you can understand by taking the example of benzaldehyde. Very simple way, reaction will be as it is. Formaldehyde, H was there, HCHO. Now in the place of H, phenyl group is attached, C6H5, or benzene group, like you can tell, it is attached with CHO. Then same thing will happen, reaction will be the same, because always one H was retained in one molecule, one H was retained in other molecule, 2 H was there. Only CO bond broken in both. Correct? In presence of concentrated NOH or KOH, whatever be. But it should be alkaline. That is a special condition. Then again same thing will happen. Then in alcohol, you have seen in methanol, that is 2 hydrogen attached, one came as H minus, other as H plus. Correct? There 2 hydrogen attached, you know, one went with oxygen, other went with carbon. Then there actually it formed, you have seen that it has formed potassium formate, it was forming, and methanol. In these two product was there. Then in methanol, actually 2, in the place of 1 hydrogen, 1 phenyl will come. In the place of methanol, Just one H remove and add one phenyl group, C6H5. Then it became, now with carbon CH2OH will remain and one phenyl group is attached. C6H5 or benzene ring with that CH2OH. Then now this methanol converted to benzoyl alcohol. Same mechanism, no difference. Only in the place of H, phenyl group is there, that's enough. And other was potassium formate. Potassium formate, you have seen that C carbon was having these things, C double O and O negative. First formaldehyde, you remember, in the mechanism, C double bond O and one oxygen negative was there. There I can say potassium came. Here suppose NOH you have taken, then sodium will come. Then this is actually formate, correct? And in the place of 1H, phenyl group came. Then now it will become sodium benzoate, means benzene group, with benzene group C double bond O, again ONA is there. ONA is there. In the with C double bond and O was there, negative, there sodium plus Na plus will come. Then now here will get sodium benzoate. Then here benzaldehyde, 2 molecules of benzaldehyde gives 1 molecules of benzyl alcohol, means C6H5. After that CH2OH is attached. In that benzene CH2OH is attached. Here you remember, in benzaldehyde no alpha hydrogen is there because CH is attached with the benzene ring. Then there 3 bond is already there. One double bond in ring and one single bond. Fourth one is attached directly with CHO. And there is no hydrogen, no alpha hydrogen. Okay, this you remember. Now next reaction I am telling you, that is the electrophilic substitution reaction. Electrophilic substitution reaction means here just to take the example of benzaldehyde only. One benzaldehyde you have taken, then one benzene ring is there, one CHO group is attached. Here what will happen? Substitution, electrophilic substitution means E plus, as for example E plus NO2 plus, NO2, N will have positive charge. That is example of now you can say electrophile. Then this NO2, how will you get this NO2 in having positive charge? How will you get? Then you will get in the presence of HNO3 plus H2SO4. That will give you NO2. Okay. And how we will give H2SO4 and HNO3? Then HNO3, you can write HNO3 as a NO2 and OH. NO2 and OH, it is HNO3. Then OH will go as a minus. Then OH will go as a minus. Then nitrogen will become positive. And this OH and when this OH and hydrogen coming from the benzene, that H and this OH will form water, H2O. Then what will happen to this H2O? Then this H2O will be absorbed by H2SO4 because H2SO4 is dehydrating agent. In the presence of H2SO4 only this reaction will take place. Means OH of HNO3 and H of benzene will make water in presence of H2SO4. It will absorb. Okay, this is the role of H2SO4. Then now come to the electrophilic substitution reaction. Then when H will go as a H plus from the benzene ring, only in benzene ring aldehyde group is attached. Then H plus will be replaced by another plus. Plus can be replaced by other plus. That is called substitution, replacement, having the same charge. Then H plus gone outside, in the place NO2 came because H plus went. Then that carbon became negative. Then that's why this plus NO2 will join there. and it will join at meta position, means with respect to CHO in the ring, that is the this ortho meta para. Then CHO group is deactivating and meta directing group. Then this a plus NO2 will join to the meta position, correct, because H gone as a H plus, then that carbon becoming negative, then this plus NO2 will join there. Same way how H was joined there, same way it will join there. Okay, this is called electrophilic substitution. Then here aldehyde plus aldehyde, benzaldehyde, it will react with you can say HNO3 and H2SO4. In the presence of both, this aldehyde will react, and temperature you have to maintain 273 to 283 Kelvin, and then it will produce NO2 plus NO2 that will join at meta position. Then it will be called, product will be called meta nitrobenzaldehyde. Okay, I think you have understood. Now I will discuss uses of aldehyde and ketones. Uses of aldehyde and ketones. Actually, its uses are very, very important. Every time in many examination question is asked, and it has many applications that I am telling you. First, in chemical industry, aldehyde and ketones are used as solvents. In chemical industry, aldehyde and ketones are used as a solvent, just like water. Water is used as a solvent in many reactions, correct? Like that way. This aldehyde and ketones are used as solvents in chemical industries, and also as a starting materials, means you can make further product. Then this is used as a starting materials, and reagents. Reagent also know A plus B will give C plus D product. Then A and B are called reagent. Reactant, what you are telling? Reactant. Here you can tell reagent. Then two reactants are required. Then both reactants are called actually reagent only. Then here it is used as reagents. Reagents for the synthesis of other products. Now particularly I am telling you formaldehyde. Formaldehyde is well known as formalin. What is the formalin? Then 40% formaldehyde solution is known as formalin. 40% question is asked. It is a fit question for medical. It is asked in any examination, but it is fit for medical. Why? Because it is used to preserve biological specimens and to prepare bakelite. This formaldehyde is also used to prepare bakelite. It is used as preservative, I told you, to preserve biological specimen, and it is also used to prepare bakelite. What is a bakelite? Then it is a phenol formaldehyde resin. When phenol will attach to the formaldehyde, then it gives a resin. Product is known as resin. Then it is used to prepare bakelite. Okay, just like bakelite means you can understand, just like these things, rubber, natural rubber is there, like that way you can understand. Okay, bakelite, you will study these details in polymers. Then it is used to prepare bakelite. Also it is used to prepare urea formaldehyde glues, GLUES, urea formaldehyde glues as adhesive, and other polymeric products also. Many other polymeric products are formed. Now for acetaldehyde particularly, what is used, where it is used? Then acetaldehyde is used primarily as a starting material in the manufacture of acetic acid, ethyl acetate, vinyl acetate, polymers and drugs. See the usage of acetaldehyde. It is used primarily as a starting material in the manufacture of acetic acid. Second, ethyl acetate. Third, vinyl acetate. Fourth, polymers. Fifth, drugs. Now come to the benzaldehyde. Benzaldehyde is used in perfume, in perfume. in perfume it is in the preparation of perfume it is used. Benzaldehyde is used in perfumery and in dye industry, color preparation dye. DYE, dye. Benzaldehyde is used in perfumery and in dye industries. Acetone and acetone, but now use of acetone you can tell. Use of acetone. Acetone and ketones are these things. Acetone and ketones are can say used as a solvents. These acetone and ethyl methyl ketone. Also you can tell another example. Acetone and ethyl methyl ketones are common industrial solvents. Nail polish, you might be knowing nail polish. There as a solvent acetone is used. It is volatile. If you will keep it bottle open, then it will solidify. That this acetone will evaporate. Hence quickly it is just cover you have to put. Otherwise only solid will remain. Acetone will go outside. It is volatile. Then acetone and ethyl methyl ketone are common industrial solvents. Many aldehydes and ketones as for example butyr aldehyde, vanillin, acetophenone, camphor, etc. are well known for their odors and flavors. These butyraldehyde, vanillin, these will give a special odor and flavors. Even acetophenone, camphor, all will actually give a special odor and flavor. Correct? These vanillin and other in ice cream you have seen. They will sell in different name. Then for these you can say butyraldehyde, vanillin, acetophenone, camphor are all well known for their odors and flavors. Okay. Then now aldehyde and ketones finished. Now in this chapter carboxylic acid is remaining. Then that I will start next class. Thank you.